Okay, this is my solution for the problem that we did on Monday of week 5. And we had this little device called the Whirligig, and we had a tube and then a string that went through the tube, and I was holding on to the tube, but it was really the mass, that's my hand, I have a lot of fingers there, okay, it was the mass hanging down on the bottom that was causing this littler mass to go around in a circle. So we can call this the big mass M, and call this the little mass, little m. And so what we did is we observed that it would be 2 revolutions per second when when the length of the string r, when r was 30 centimeters. And the mass hanging down on the bottom was 200 grams. Okay, and the question was, find the mass of the little stopper. And how we did that was, of course, choosing the little stopper and making a free body diagram. So there was little mg downward, there was the force of tension that goes back inwards to the circle, and that's pretty much it. Now, one of the things we noted here is that what's really going on is that this thing has a little bit of an upward angle to it. In fact, it has to have an upward angle to counteract the gravity downward. But we decided to neglect that little effect in the beginning and just say then, therefore, that the sum of the forces in the x direction, if we choose this to be the x direction, is the force of tension, and that has to provide the acceleration, mv squared over r. It's then necessary to do really a second free body diagram, and the second free body diagram has the mg of the weight and the force of tension upward. And because it's not accelerating, the sum of the forces here, not accelerating, that means that the force of tension minus mg is equal to 0. So the force of tension here is big mg. So now we can combine this relationship and this relationship into one formula, and it looks like this. It looks like mv squared over r is equal to big M times g. So the question is, we didn't really measure r. Well, no, we did measure r, sorry. What we didn't measure was v. And so what we have to do is figure out v in terms of the things that we did measure. So I know that the velocity of something going around in a circle is its circumference. Circumference divided by its period. And this word is the time for one revolution. So sometimes we write the period as p, and if I do that, this is 2 pi r all over p. And so v squared is simply this thing squared.
All right, kids.
Okay, fair enough. So let's see. So we had m from before. We had m v squared over r was mg. And so this becomes m over r, 2 pi r over the period squared is mg. And this little factor of r and these really 2 factors of r we can simplify. So this becomes m 4 pi squared r over p squared is equal to mg. And we know that p from the observation is half a second. Okay, so that means that little m is equal to 0.2 kilograms times 10 meters per second squared times 0.5 seconds squared divided by 4 pi squared 0.3 meters. So I'll pause here and type all that into my calculator. Okay, I'm back, and I plugged that all into my calculator, and I get that m is equal to 4.2 times 10 to the minus 2 kilograms, which is, let's see, which is in grams. So, times 10 to the minus 2, so 0.042 kilograms, which is 42 grams. And that's the answer.